Welcome to Section 6.1, Rational Expressions and Functions, Multiplying and Dividing. Okay, so first off, what is a rational function? Well, it is a function, and this goes into further detail in your book on page 386 if you'd like to see it, but it's a function, f of x generically, which has a polynomial on the top, which we call p of x, and a polynomial on the bottom, which we call q of x. So notice this is a fraction, hence the name ratio, rational expression, like a fraction. So we're talking about basically fractions with polynomials. One thing we have to keep in mind is where q of x cannot equal 0. Why does that matter? Well, recall, in the denominator of a fraction, it can never equal 0. Why? Because that is undefined. Okay, so q of x cannot equal 0. So with that in mind, the concept that q of x cannot equal 0, let's take a look at example 1. Give the domain of the following functions. So once again, when we think of a domain, what are we thinking about? We're thinking about the values of x that we use or the values of x that we're allowed to use. So one thing to look or note about all of these is that they're all fractions, which means we have a problem. A red flag should pop up in your head. We know that the denominators can never equal 0. All of these, we can never let an x value be plugged into these that would make them equal to 0. So how do we solve that? Well, we're going to find the problem number and then take the problem number out. How do we find the problem number? Well, we're going to go ahead and take the denominator, x plus 5, and set that equal to 0. What are we doing? We're trying to find the number that makes the denominator 0, and then we'll take that out of our number line. So let's solve for x. Minusing from both sides, we get x equals negative 5. So this number right here is the problem number. If I plug negative 5 into the denominator, what happens? Well, negative 5 plus 5, what would that give me? That would give me 0 in the denominator, and we can't have that. So on our number line of all the real numbers, the only number we're not allowed to have is negative 5. So in our solution, we can allow any other number but negative 5. Now how do we answer this? We're going to write the domain of f of x is going to equal what? All numbers, negative infinity all the way up to 5, but we take out 5 because it causes a problem. So negative infinity to negative 5. Stop, take out negative 5, and then we're going to continue on to positive infinity. So union negative 5, infinity. And that right there is the domain. So once again, how do we find the domain of a rational function? We look at the denominator and we take out the problem number. So real quick, there is a small typo. This function, k of x, should equal 2 over x squared minus 1. Okay, so we're looking at this right here. Alright, so once again, we need to look at the denominator and then we'll find the problem number after we set it equal to 0. So x squared minus 1 equals 0. Once again, why are we doing this? We're testing it to see what number causes the problem. Alright, and I know how to factor this number. This is going to be x plus 1 and x minus 1 equals 0. And then, setting each of these equal to 0, we have x plus 1 equal to 0 and x minus 1 equal to 0. Subtract 1 from both sides, and we get x equals negative 1. And then add 1 from both sides, and we get that x equals 1. Oh, so this time, we don't have one problem number, like we did on this problem. We actually have two numbers that cause a problem. So on my number line, the two that I'm going to take out are negative 1 and 1. But every other number on the number line is allowable because they don't make my denominator 0. So what would my domain be? My domain of k of x is going to be negative infinity to negative 1, union, negative 1 all the way up until positive 1, and then we're still continuing, union, 1 to infinity. Ooh, that was a big one. Okay, kind of squishing in, but we got this. All right. So the last problem, once again, we're trying to find the domain, and the way we find that is by setting the denominator equal to 0 and solving. So 2x squared plus 11x plus 5 equal to 0. Now to solve this, I need to factor this. Alright, so let's go ahead and factor. And I'm going to use the zero factor property. So let's see, for my testing, I know the factors of 2 are just 1 and 2, and the factors of 5 are just 1 and 5. Now, what do I want to do? I want to add those to get a positive 11. Well, 1 times 2 and 1 times 5, if I go ahead and do the testing this way, so 2 times 5 is 10, and 1 times 1 is 1. When I test that way, I can add these two and get that positive 1 on the inside. So then there's the 2 times the 5, so it's going to be 2x, and that goes to the 5. And then we get the regular x, and lastly we have the 1s. Alright, so it has been factored. Let's go ahead and solve. So set each factor equal to 0. 2x plus 1, set that equal to 0. And then x plus 5, set that equal to 0, and solve. Minus 1. 2x equals negative 1. Let's go ahead and divide by 2. So x equals negative half. And let's solve the other side. Minus 5 from both sides. And we get x equals negative 5. So this is a little squished, but on our number line, what numbers do we take out? We take out the negative half and the negative 5, and negative half is a little bigger. Okay, so those are the two numbers that we can't allow. Why? Because they make our denominator equal to 0. So any other number is allowed except for those. So my domain, once again, sorry for the lack of space, domain of h of x is going to be negative infinity to negative 5. Boop, take out the negative 5. Union negative 5 to negative half, right in there, and then take out negative half, and then we continue on to negative infinity. So negative half to positive infinity, and open parentheses at the end. And box our answers. Okay, so that is how you find the domain. Set the denominator equal to 0, solve, and then those numbers that you get are the ones you take out of your interval. Okay, so let's take a look at example 2. Simplify the following rational expressions. So how do we know that these are rational expressions? Well, we have a polynomial divided by another polynomial, so this is rational. The next thing is, what does it mean to simplify? Well, basically, you're going to factor and then see if any of the factors cancel. So the one in the top, is it factored or not? Let's see. Well, it's just 3 times x in the top, so we know that's already factored. Now on the bottom, that is not factored. It's just an addition problem going on. So let's go ahead and factor out the 3, and then we have x plus, let's see what, 5 in the denominator. So what would that equal? Oh, one thing to note, I think I pointed out in my videos before, but you notice on exams I do make sure that you always write your equal signs as you're simplifying. So always make sure to do that. Okay, so back on track. So I'm trying to simplify this. Now I factored it, that was the first thing. The next thing to do is to see if you can cancel common terms. What do I mean by that? Well, if we have multiplication problems going on, I can cancel the same term. And notice we have 2 3's. So I can cancel this 3 and cancel that 3. And then I'm left with x divided by x plus 5. And we're done because we can't factor anymore, which means we have nothing else to cancel. Now you might say, but wait, why can't I cancel that x and the other x? Why can't I cancel these two? The reason is that x is being added to the 5. We cannot cancel something that's being added or subtracted. We could cancel this 3 because it was being multiplied to this binomial, and this 3 was also being multiplied to the x. So be careful about when you're trying to cancel. Let's take a look at the next one. I'm going to rewrite it. 3y squared minus 12 divided by 3x minus 9. So there's a small typo here, sadly. That should be a y as well. They should both be y's. And then that should not be a 9. That should be a 6. Let me go ahead and erase that. So that should be a 6. Sorry for the typo there. Alright, upside down 9, 6. Same thing, not really. Okay. So, once again, what's the plan? First we're going to factor, and then we're going to cancel. If we can cancel. And if we can factor. Can we factor? Well, on the top, 3y squared minus 12, the 3 and the 12 both share a 3 in them. So let's go ahead and factor out 3. We're left with y squared minus 4. Divided by. Now in the bottom, we have 3y and 6. Ooh, they both share 3. So let's go ahead and take out a 3, and we're left with y minus 2. Now, are we completely factored? On the bottom we are, but on the top, notice this binomial here is special. Why is it special? It's the difference of squares, you're right. Okay, it's the difference of squares. So we're going to go ahead and factor that. That'll be y minus 2 and y plus 2 divided by 3, y minus 2. All right, so everything is factored. Can we cancel anything? Are there any like terms? What do I mean by, are there any like factors? Once again, which ones of these are factors? This 3 is a factor, that's a factor, that's a factor, that's a factor, and that's a factor. All the ones that are separated by multiplication are factors. So can we cancel any of these? Are any of these the same? We can. The 3's are the same, and so are the y minus 2's. So what are we left with? We're left with y plus 2 divided by 1, which is the same thing as y plus 2. And we'll go ahead and box our answer. And once again, another important thing to note, equal signs all the way down the side. That is something that I do grade for. I believe I mentioned it before, but I'm just mentioning it again. All right, example 3, do as indicated. Well, what is being indicated? In this first problem, what do we have? Oh, let's take a look. We have fraction polynomial and fraction polynomial, and then, we have a division sign. Okay, so let's go ahead. What would we do with this? Well, in general, I don't like division, so let's change this from division to multiplication. So we're going to go ahead, change that, and then we get 9t divided by 3t plus 6. All right, so we got that figured out. So the next thing we need to do is let's go ahead and multiply them together. So we have 8t squared times 9t all over t squared minus 4 times 3t plus 6. Okay, so the next thing we're going to do is we want to simplify. As usual, you always want to simplify your answers, right? So this is going to be similar to like what we did earlier. We need to make sure everything is factored. Well, in the top, they're basically factored. We have the t squared. Actually, I'm going to go ahead and combine these two. So we have 8 times 9 and then t to the third power divided by. Now in the bottom, are they factored? The answer is no. That is a difference of squares. And this one, we can factor 3 from that 3 and 6. So factoring that, we get t minus 2 and t plus 2. And then we can factor out that 3, so we have 3t plus 2. So once again, these guys came from this one right here, and this one factored out into that. So now everything is a bunch of multiplication. So how many factors do we have? We have 1, 2, 3, 4, 5, 6, 7 different factors. Can any of them simplify? Well, the 3 and the 9 can be simplified, so we're left with a 3. And then can anything else in the numerator simplify? No, that's it. It's a little disappointing, but that's all that we can simplify. So we're left with 3 times 8, which is 24t squared, all over t minus 2 times t plus 2 times t plus 2. And we're going to leave it factored. Why? Because we're asked to do as indicated, and you always want to leave simply. Okay, so leave your answer as simple as possible. And we're done. Not too much canceled there, not as fun. So let's take a look at the next one. This one's a lot bigger. So we have 3 trinomials and then 1 binomial. Now you could go ahead and just multiply them, but that would make life really hard. So what I want to do is I'm going to go ahead and factor them all first before we do any multiplying. Well, the top x minus 6 is already factored, but let's go ahead and factor the bottom. So we have x squared minus 12x plus 36. So that's going to be x, let's see, minus 6, x minus 6. Yeah, that sounds right. 6 times 6 will give me the 36, and 6 plus 6 will give me the 12. Then multiply 2. In the top one, we can go ahead and factor that 2. Let's see. X, and we want to have something that multiplies and gives me 8 and subtracts and gives me 3. Let's see, that seems like 3 and 6. 3 times 6 is 18, and then negative 6 plus 3 would give me that negative 3. So we'll have negative 6 and positive 3. And then in the bottom, we'll go ahead and we have x and x, and we want some factors of 12 that will give me 7, 3, and 4. Okay, so now it's all factored, and that's always the best thing to do is factor it first, make things simpler. Next, we could go ahead and multiply all into one fraction, or we could just go ahead and simplify now. So are there any factors that are the same? Well, we have that one x minus 6 and that other x minus 6, so we can cancel those. And we also have two other x minus 6. Once again, you can only cancel one item from the top with one item from the bottom, so be careful. And then we have, the x minus, or x plus 3s. We can cancel those as well. So what do we have left? Well, there's nothing in the top, so it's just a 1. And then in the denominator, we only have x plus 4 left. And that's it. We're done. Wow, that one simplified a lot. Alrighty, so that's it for this section. Once again, make sure factor first, simplify, and then cancel. So this means you really have to have factoring skills down. So if you're struggling with factoring, trinomials or anything, please just let me know, send me an email, and I can give you some practice problems. Alrighty, that's it. Feel free to drop by my office hours if you have any questions.